All right, this is your extra examples for section 5.4. We'll use the sum or difference identity to find an exact value. To get 15 degrees, I could take 60 minus 45. Let's do cosine of 60 degrees minus 45 degrees. It doesn't matter which numbers you choose as long as they make that 15. So I take cosine of the first times cosine of the second plus sine of the first times sine of the second. Cosine of 60 degrees is 1/2. Cosine of 45 is square root 2 over 2. Sine of 60 degrees is square root 3 over 2. Sine of 45 is square root 2 over 2. Combine these, I get square root of 2 over 4 plus square root of 6 over 4. Add them together, I get square root of 2 plus square root of 6 over 4. All right, 17 pi over 12. So I need to find two numbers that add or subtract to give me that. So I start by thinking, all right, 17 pi over 12. I could do 15 pi over 12 plus 2 pi over 12. And 15 pi over 12, if I divide them both by 3, I get 5 pi over 4, which is on the unit circle. And 2 pi over 12 is pi over 6, which is also on the unit circle. So let's go with that. We're doing the sine of 5 pi over 4 plus pi over 6. If I got numbers that weren't on the unit circle, I'd just try different ones. So sine of a sum, I take sine of the first times the cosine of the second plus cosine of the first times the sine of the second. You may be saying, how do I know which one's first and second? It doesn't matter, it'll work out the same. So sine of 5 pi over 4 is negative square root 2 over 2. The cosine of pi over 6 is square root 3 over 2. The cosine of 5 pi over 4 is negative square root 2 over 2. The sine of pi over 6 is 1/2. Multiply, I get negative square root 6 over 4 minus square root 2 over 4. Combine them into one fraction since they've already got that common denominator. Our answer is negative square root 6 minus square root 2 over 4. All right, tangent of 5 pi over 12. I could take a sum or a difference here. Let's say I look at 5 pi over 12 and I say I could do 6 pi over 12 minus 1 pi over 12. Well, 6 pi over 12 simplifies, but 1 pi over 12 doesn't. I can't use that. I could, though, say 2 pi over 12 plus 3 pi over 12, which would be pi over 6 plus pi over 4. That will work. So we want the tangent of pi over 6 plus pi over 4. So we take tangent of the first plus tangent of the second over 1 minus tangent of the first times tangent of the second. Now things get wonky with tangent. Tangent of pi over 6 is square root 3 over 3. Tangent of pi over 4 is 1. Square root 3 over 3 times 1. All right, we need a common denominator in the numerator. So we have square root 3 over 3 plus 3 over 3. Same thing in the denominator. I'll do 3 over 3 minus square root 3 over 3. All these denominators are going to cancel. All right, multiply everything by 3. We get square root of 3 plus 3 over 3 minus the square root of 3. That is our final answer for the tangent. All right, now we're going to go the opposite way. We're going to combine. So I see cosine, cosine, sine, sine with a plus in the middle. That is a cosine of a difference. So I could squish these back together as the cosine of two things subtracted. And it's always first minus second. I need a common denominator, so I'll turn it into twelfths. 4 pi over 12 minus 3 pi over 12, which makes the cosine of pi over 12. Had I subtracted the opposite way, I would have gotten the cosine of negative pi over 12. but the odd and even identities tell us that that is equal to the cosine of regular pi over 12. So it's fine. Either way works out. All right, let's combine this into one. I have a sine minus cosine. Well, the only way to have sines and cosines grouped together is with a cosine of a sum or difference. But the cosines have to come first. So I'm going to factor a negative out. And then I can switch my order. Now it looks like the cosine of a sum. So I have a negative out front, the cosine of two things added together. Those two things are x and 2x. I have negative cosine of 3x is how that simplifies. All right, now I don't know the sine of 25 or the cosine of 35, but I could smush it into one single function. Sine, cosine, sine. That tells me I'm doing a sine. And sine, the center term, or the center symbol, matches when we put it together. So it's just those two angles added together. The sine of 25 plus 35 degrees. So we are looking for the sine of 60 degrees. And guess what? I can figure that out. The sine of 60 degrees is square root 3 over 2. All right, same type of idea. I can't do this without combining them. Cosine, sine, that tells me it combines into a cosine. With cosine, the middle symbol is the opposite. So I take my first angle, 11 pi over 20, plus my second angle, which is pi over 5. In radians, we have to get a common denominator. So that'll be plus 4 pi over 5, or 4 pi over 20, sorry, which makes the cosine of 15 pi over 20, which then I simplify again to 3 pi over 4. And I can do the cosine of 3 pi over 4. That's negative square root 2 over 2. All right, and now we're going to do some problems where it tells us some values and quadrants. I like to start with a picture. All right, alpha is in quadrant 3. Boom, there's alpha. The sine is negative 4/5, so opposite over hypotenuse, which tells me that the adjacent side is 3, but negative because we're in the third quadrant. Beta is in quadrant 2. It tells me the cosine is negative 5/8, so I'll label my sides accordingly. And to get that third side, it's the square root of 64 minus 25, the square root of 39. Okay, not a nice number, but that's fine. I have the cosine of a minus b, so I want the cosine of a times the cosine of b plus the sine of a times the sine of b. Cosine of a is negative 3/5, looking at that triangle. Cosine of b is negative 5/8. The sine of a, looking at this triangle, is negative 4/5. The sine of b is square root of 39 over 8. So we combine. I get 15/40 minus 4 square root 39 over 40. Remember that it's easier to not simplify when you multiply here because I've already got a common denominator. 15 minus 4 square root 39 over 40. That doesn't simplify. That is my answer. All right, same type of problem. Start off with a picture. Alpha is in quadrant 2. And I know that the sine is 5/13, so opposite over hypotenuse. 5, 12, 13 is a special right triangle. Negative because that x value should be negative. Cosine of b, b is in quadrant 4. The cosine is adjacent over hypotenuse, so that means the missing side is square root of 11, but negative because it's going down. All right, I have sine of a plus b, so that breaks apart into the sine of a times the cosine of b plus the cosine of a times the sine of b. So the sine of a is 5/13. The cosine of b is 5/6. The cosine of a is negative 12/13. The sine of b is negative square root of 11/5. I get 25 over 78 plus 12 squared 11 over, I apologize, this should have been a 6. What am I doing here? Over 78. Add those two fractions together. They've already got a common denominator. And nothing goes into all my terms, so I'm done there. And another. This one, I actually would say, all right, the tangent inverse is an angle. Let's call it A. Cosine inverse is an angle. Let's call it B. I want the sine of A plus B. Okay, I can break that apart. It's the sine of A times the cosine of B plus the cosine of A times the sine of B. Now we have to figure out what A and B are. Actually, we're not going to find A and B. Tangent inverse of a negative, that's going to be in the fourth quadrant. I'm calling that angle A. Tangent is not negative 9 over 40, so opposite over adjacent, that opposite gets the negative. I can find my missing side using the Pythagorean theorem. And this doesn't happen to be one I know off the top of my head, so I'm grabbing my handy calculator. Oops. Square root of 40 squared plus 9 squared. 41. And then B, it's a cosine inverse of a positive value, so that's the first quadrant. My cosine is adjacent over hypotenuse, so 8 over 17. And my missing side, square root of 17 squared minus 8 squared, it is 15. Now I can fill in my numbers. The sine of angle A is negative 9 over 41. The cosine of angle B is 8 over 17. The cosine of angle A is 40 over 41. The sine of angle B is 15 over 17. These are going to be some nice big numbers. I have negative 72 over 697 plus over 697 again. 40 times 15 is 600. Combine my fractions, I get 528 over 697. Now I'm not positive if that will simplify or not, so I'm just typing in my calculator quick. It doesn't. There's our answer. And another just like that, except I know the arcsine of a half. Arcsine of a half is pi over 6. And I know the arc cosine of square root 2 over 2. That's pi over 4. So I'm trying to find the sine of pi over 6 minus pi over 4. That'll be the sine of pi over 6 times the cosine of pi over 4 minus the cosine of pi over 6 times the sine of pi over 4. Sine of pi over 6 is a half. Cosine of pi over 4 is square root 2 over 2. Cosine of pi over 6 is square root 3 over 2. Sine of pi over 4 is square root 2 over 2. Multiply, I get square root 2 over 4 minus square root 6 over 4. Combine into one fraction, square root of 2 minus square root of 6 all over 4. That takes us back to the beginning. And one final problem. Again, we're going to want to draw triangles for this one. So my sine inverse is going to give me what I'll call angle A. My tangent inverse will give me what I'll call angle B. Cosine of A plus B is cosine of A times cosine of B minus sine of A times sine of B. So let's draw pictures. Sine inverse of a negative means that it'll be in the fourth quadrant. So angle A is in the fourth quadrant. Sine inverse means the opposite is negative 12. The hypotenuse is 37. Find that other side using Pythagorean theorem. I get 35. And tangent inverse of a positive means we are in the first quadrant. Opposite is 5, adjacent is 12. Pythagorean theorem, I should know this one, it's 13. Okay. Now we'll plug in our numbers. The cosine of angle A is 35 over 37. The cosine of angle B is 12 over 13. The sine of angle A is negative 12 over 37. The sine of angle B is 5 over 13. Multiply. 35 times 12 makes 420 over 37 times 13 is 481, minus negative, so plus, 12 times 5 is 60, over 481. Add those together, I get 480 over 481 as my final answer.